In the previous video, we learned how to create conditional routes in LangGraph, where our graph intelligently decides which node to visit next based on user input or data state. But what if we want to chain multiple conditional flows together, like a series of choices where one operation leads to another? That's exactly what we're going to explore today. So in this video, we're taking things one step further and see how LangGraph can handle multiple branching routes, letting you create more complex and intelligent workflows that don't just stop after one choice. So we'll first write down the code and then I'll explain you the code here. Okay, so let me create a new file here. For underscore complex conditional dot ipynb. So first of all, I'll have my code. I'll have my imports here. So the import are going to be from LangGraph dot graph import state graph start and end, and from typing I will have type dict. Okay, choose the interpreter, and then while this runs, I'll create my agent state. So agent state, this will be have a parameter of type dict. So type dict, I'll have number 1 here, number 1 as integer, number 2 also as an integer, and I'll have number 3 as an integer, number 4 also as an integer. I will have operation 1 as a string, operation 2 also as a string, and then I'll save the result of operation between number 1 and number 2 in result 1, which is going to be an integer, and similarly operation 2 for number 3 and number 4 is going to be saved in result 2, which is also an integer. Okay, so let me run this. So while this is running, now we'll create our functions here. So first of all, we'll have adder, where we'll pass the parameter as agent state. It will again return an agent state. So I'll update state result 1 equals to state number 1 plus state number 2, and then I will return the state here. So let me copy this and then create another subtraction operation here. So I will have subtractor2 or sub. Okay, I'll write the full function name subtractor2, where I'm going to subtract these two, number 1 and number 2 here. Similarly, I'll have adder2 and subtractor2. So let me just copy this down and then copy it here. So here I'll have adder2. The result will be stored in result 2. The numbers are number 3 and number 4. Similarly, in subtractor2, we are going to store the result in result 2, where the numbers are number 3 and number 4. Okay, we also need to create two router functions, so let's do that. Choose next node 1. It will have a state of type agent state, and then it will return a string. So if state operation 1 is equal to plus, then what we want to do is we want to return add 1. Else if state operation 2 is equal to minus, then we want to return sub 1. Okay, I'll also create a router for our number 3 and number 4 part here. So choose next node 2. Okay, sorry, this has to be operation 1, and then here we'll have operation 2, add 2, operation 2, sub 2. Okay, so these are our router nodes. Now we'll go on to create our graph here. So graph equals to state graph. I'm not sure why the suggestion is not being shown, but anyway, agent state, I can just type this. First of all, I'm going to add my first node here. So the first node is adder1, and then I'll give a name adder1 here. Similarly, I have my second node, add underscore node. This is subtractor1. Let me write down the function name here, which is, okay, what do you name it? Okay, subtractor1. Subtractor1. Similarly, I have adder2 and subtractor2, which I'll just create here by copying this. Adder2 and then subtractor2. Now I'm going to add a node for router 1 and router 2, which will basically act as a pass-through function here. So router 1 will pass lambda state and then basically pass the state here. And then similarly in router 2, this should have been a comma. Okay. And then in router 2 will do the same thing. So router 2 lambda state. Okay. Now what we'll do is we'll start adding edge. So the first edge is going to be from start to router 1. Then I'll add a conditional edge here. So add conditional edges. Now the detail of this conditional edges is from router 1, it will go to the choose next node 1, and from here we have two options. We can either go to okay, what is the function name? Let's see. So add1 and sub1, right? So we can either go to add1. So if add1 occurs, then we go to adder1, and if sub1 occurs, we go to subtractor1. Now I'll add one more edge here. So add edge from adder1 to router 2, and then subtractor1 to router 2, whichever works in the following case here. Adder1 and subtractor1 both should go to router 2 here. Now I'm going to add another conditional edge for router 2 here. So the name is router 2, comma, and after this the function is choose next node 2, and then within this I'll have one more I'll have add2 which will go to adder2, and sub2 which will go to subtractor2. Now after this I'm going to add two edges, either from adder2 to end and subtractor2 to end again. Now this is my final graph. Let me compile this, graph.compile, and then if I print the board, then we will see our conditional graph here. So from start we'll go to router 1, and then either to add or sub1 depending upon the operation, and then we'll go to router 2 and then add 2 to sub 2 depending upon the operation that we have. So now what we're going to do is we are going to finally run this using our input state. Let me provide the input state. I'm just going to copy this here. So number 1 is 1, number 2 is 2, the operation is plus. So basically we need to see the result 3 in result 1, and then in case of number 4 and number 7 we need to see the subtraction operation here. So now what I'm going to do is result equal to bot.invoke, and then provide the input state here, and finally we print out the result. and then we can see our result here. So what did we do here? We started by defining an agent state that holds two separate mathematical operations. So each operation has its own pair of numbers and operators, one for each step and then one for the second. Now we define four simple nodes here, two adders and two subtractors. So each of these nodes does the operation and store the result back into the state. But the interesting part here is the two routers that we have. So router 1 and router 2. So these routers act like our checkpoints where choices are made. The first router looks at operation 1 and then chooses whether to go to the first adder or the first subtractor, and then similarly for the second router again. So LangGraph handles this beautifully with multiple conditional edges joined together, allowing our graph to branch and rebranch as per needed, just like how complex reasoning systems work in the real world. It's a simple yet powerful demonstration of how LangGraph gives you total control over your workflow direction without any hard-coded if-else change in your logic. So now, instead of having a single choice, your system can make multiple sequential choices, each one based on the updated state of the graph. So this opens the door to designing more intelligent multi-step workflows like multi-turn reasoning, agents, multi-stage data processor, or even complex system that can react to evolving inputs.